Graph the line y equals 2x plus 4. What's the angle in degree mode that the line makes with the x-axis? So if we graph this line, we have a y-intercept at 4, slope of 2, just like that. Okay. You'll notice that the line makes an angle with the x-axis right here, and you can see the angle is formed right there. Okay. You'll also notice that based on what we've drawn here, we can definitely see that a right triangle has been formed. Let me outline that so you can see a little better. We see that there's a right triangle formed right here. And with this right triangle, we do see that there are side lengths of 4, right? And also a side length of 2. With that said, this allows you to be able to think about what that angle theta actually represents. Since theta is formed with those two side lengths, we can actually use some trig ratios here. Specifically, tangent of theta would give you opposite over adjacent, and the opposite side being 4, and the adjacent side being 2. So with this here, we can see that theta is equal to the tangent inverse of the value of 2. And with our calculator, tangent inverse of 2 is going to give us, in degree format, an angle of 63.43 degrees. Okay, so theta is equal to 63.43 degrees. So that's kind of the angle that the line makes with the x-axis. For b, y equals half x minus 3, we can do the same approach here. We can graph that line. So half x minus 3 would give us a y-intercept at negative 3, a slope of 1 over 2. And so I'm just going to go ahead and plot this. Okay, just like that. And what we want to do is, similarly, we want to see what angle it makes with the x-axis. Now notice here that the x-axis, if we extend it a little bit further, we can see that angle being formed. You'll actually notice that there's probably two angles that you see here. One being this particular angle, and then the other one being the acute angle. What we're really more focused on, though, is the acute angle, because remember that angles are always formed as the initial ray goes up counterclockwise and reaches your terminal ray. So our angle being formed is right here. Now, it's a little bit hard to see because you can see that the grid is off the page now. But I'm just going to use a little bit of geometry here just so that it works a little bit easier in my favor. So this angle theta here, I'm just going to give it another angle name. Let's call it angle alpha here, just so that I don't confuse you with the part A here. Okay, so that's angle, sorry, not angle, that's angle alpha, angle alpha. And so angle alpha, you can see, forms another triangle. Remember that when it comes to geometry, we can see that there are congruent triangles here, and they have the same angle measure here. And so we again form another right angle here. And so this, this triangle was formed by having a side length here of, it looks like 6, and also a side length here of 3. So we've got our triangle here, and we've got our angle alpha, and we want to find that angle alpha. Again, because we have 3 and 6 there, we're not using the hypotenuse of this triangle, and so it looks like we'd want to use tangent again. So tangent of alpha is equal to opposite over adjacent, where opposite in this case is 3, and adjacent would be 6 to that angle alpha. And so therefore alpha is equal to the inverse tangent of 3 over 6, or 1/2. Okay, and then going ahead and plugging that into our calculator again. Tangent inverse of 1/2 would give us a value, an angle measurement of 26.56 degrees, or 26.57 rather. So alpha is equal to 26.57 degrees. Okay. So that's the angle it forms with, the line forms with the x-axis. So in both of these demonstrations, hopefully what you saw is that really if you want to find the slope of the line, you're really just finding the tangent value of it, right? So in general, the slope of the line is really the same as tangent of that given angle. Okay, so slope of a line is tangent of the angle, where let me write that down, where theta is the angle the line makes with the positive x-axis. Keep in mind here what I'm writing is the positive x-axis. Notice that we always form the angle that was going this way, right? And you can also see it there. It was also going this way. It's always with the positive x-axis. Okay. And also, because it's formed with the positive x-axis, notice that we always went in a counterclockwise direction. We're always going in the positive direction. So you always want to make sure that your angle of inclination, this theta, which is what we call the angle of inclination, that's basically what we're trying to find here. It's always going to be a measure that is between 0 and 180 degrees. Right, it has to be between 180 degrees because there is a possibility where you have a, let's say, a negative slope, and therefore your angle of inclination would actually be this angle right here, where it's with the positive x-axis and it is going in the positive direction.